So, changing the constant coefficients. The first glance, as you see, this is also a Cauchy Euler equation, right? Because of this matching the degree of x here and the order of the derivative of the function here, y function here. The order is 2 here. The degree of this x is 2, 2, 2. Here it is 1, 1. Here we have x to the power 0. Here we have 0 order derivative of this y because it's not differentiated at all. That means the order is 0, right? And also on the right hand side, we do not have 0. That means that is, what is it? Non-homogeneous differential equation, right? So that's also linear because we do not have a product of y and y prime or y double prime anything. Okay. So here we're just going to talk about this changing to constant coefficients. Okay. Always by making this change, if I just make, for example, that x is equal to e to the power t, all right, if we just make this substitution, then you will see that this equation becomes linear differential equation. I mean, with constant coefficients. Okay, here we have t is equal to, from here, what is it? Natural logarithm of x, right? Now, if I make this substitution here, x squared, that is e to the power 2t, right? First, as you know that to solve this equation, the first step we need to solve the associated homogeneous part, that is x squared y double prime minus x y prime plus y. Okay, that's equal to natural logarithm of x. Or let's make this substitution here. X squared, we know what is x. I just substitute here, we have no problem. Natural logarithm of x, as you see here, it is t. Just substitute here. At first, we need to differentiate this, I mean, evaluate these things, right? From here, y is just y. Now, if I'm just changing this y of x, now I'm changing this y of x into y of t, right? Because this x is a function of t here, right? So I'm going to express everything in terms of t and y. So here, what is y prime? Y prime is dy dx, because here prime notation shows the derivative of y with respect to x. So by using chain rule, I can write it as dy dt times dt dx. Actually, not times. First, we have to differentiate t with x, and after the dy dt, and the product gives us this. Okay. Right? It's just a chain rule. Because dt cancels each other, right? And that's dy dx. Now, if I make substitution here, what is the derivative of t with respect to x? Here, if you differentiate t with respect to x, right? What is t? T equals this. If you differentiate this with respect to x, that's equal to 1 over x, right? So this dt dx equals 1 over x. So instead of this dy dx, I can write it as 1 over x. And what is 1 over x? Also, I can change this into this, right? That is equal to, because here I'm trying to express everything in terms of y of t and t. So 1 of x is equal to e to the power minus t, right? Because 1 over x, 1 over e to the power t is to the power negative t. So here dt dx equals this. I have e to the power minus t times dy dt. dy dt. Right. So now, if you differentiate this one more time, right? Y double prime. What is d square y? Here we have the x squared. That means that I need to differentiate this y's. Also with respect to x, I can do this. So that one is dy dx, right? So here actually it means d dx, and here we have, what is it? All right. We just write here. Wait. dy dx is equal to, from here, this thing is a power t dt dx, that's equal to 1 over x. So here we have 1 over x times dy dt. And the square root of y dx squared, right? We had to differentiate this one more time. That is u times v, the product of two functions, u prime. What is the derivative of this function? First, let's differentiate this thing with respect to x. So again, 1 over x times, what is dy dt? Dy dt, actually I need to differentiate this with respect to x, right? That means that is d dx, here we have dy dt. Plus, now I need to differentiate this thing, right? And actually minus comes to the front, that is minus 1 over x squared times just dy dt. Is it correct? So we are differentiating this, right? And actually we are differentiating this one, that is u times v. First, if I differentiate this one with respect to x, this dy dt, I'm differentiating with respect to x, here we have 1 over x, plus if you differentiate this with respect to x, that is minus 1 over x squared, and just the function itself here, v function, that is dy dt, right? So now if you just make some simplification here, equals, okay, dy dt, we know what is dy dt, right? And also if I just change this into x, how can I change this one? This thing is equal to 1 over x times here. Look, if I just write this one, dy dt as g, right? Differentiating with respect to x. G is a function of t. That means that first I need to differentiate g with respect to t, right? And t with respect to x. So this thing is equal to here d squared y dt squared. Yeah, just reviewing actual derivative here, right? And after that, here we have dt dx, right? Here we have dt dx. What is dt dx? Dt dx is equal to 1 over x. So here we have 1 over x, right? And with this, it is minus. Here we have 1 over x squared times dy dt. Okay. Now we have changed everything to t and y because 1 over x, I can write it as 1 over x squared times d squared y dt squared minus 1 over x squared times dy dt. Right? And what is 1 over x squared? It's a power minus 2t. Right? 1 over x squared. This is dt and everything. Now, if I just substitute here, okay. Okay, y prime we have here, right? Y double prime we have here. And just now, I need to substitute here, right? So if you substitute here, we have x squared times, and what is the common factor here? 1 over x squared, 1 over x squared, and the brackets here we have d squared of y dt squared minus dy dt minus x times, what is y prime? Y prime is this, that's equal to this. Actually in here, instead of this one, we know that dt dx equals 1 over x. So here we have 1 over x times dy dt. And here we have plus y. Plus y equals natural logarithm of x. Sorry. So now this x squared, they cancel each other, right? What we have here, d squared of y and the dt squared minus, here we have dy dt, right? X cancels each other, minus dy dt, plus, here we have y, now y is a function of t. On the right hand side, we have natural logarithm of x. Natural logarithm of x is equal to t. Okay. Now, what we got here, the differential equation, I can simplify this more, right? Because here we have the same thing here. That is y double prime minus 2y prime plus y is equal to t. Here, y is a function of t. Okay. So, as see here, Cauchy Euler equation is converted into a differential equation whose coefficients are constant. Okay, by making this substitution, we can always convert this Cauchy Euler equation into a differential equation whose coefficients are constant. Okay. So we know how to solve this equation, right? This is just need to write all the variable. The first step, m squared minus 2m plus 1 is equal to 0. And that is just, m equals 1. So from here, since m is equal to 1, we can write its solution as, the homogeneous parts. Okay, 1 is equal to 0. So this y complementary equals c sub 1 e to the power, it is 1, right? So it is e to the power t plus c sub 2 times, because of this repeated roots, we have t times e to the power t. Right? Now from here, I can change this into x again by using this substitution again. What is t? T is natural logarithm of x, right? What is e to the power t? E to the power t is x. Substitute here. And what is t? T is natural logarithm of x. And substitute here, we can solve this equation. Okay? That's the main idea. The rest is, we already did a lot of examples. That much is enough. We can continue and finish this. And this is how we make substitution. Okay, here the main idea is, if you're given Cauchy Euler equation, one way is we can look for the solution in this manner, right? We know that y is equal to x to the power m. And also without this, by using this substitution, we can first convert this Cauchy Euler equation into a differential equation whose coefficients are constant. And after that, by using our, that's so-called, undetermined coefficient, right? That's using that method, we can solve this equation. And because on the right-hand side, we have t and blah, blah, blah. So that is just the procedure that we use to solve all the differential equations in the previous lessons. Okay, Yehing, is it clear?
Yes, sir.
How many people are there here now? Let me see. 1, 2, 3, 4, 5. Okay. Okay.
No, sir, there are 8 people here.
Now 8 people?
Yes, yes.
So everybody's here now?
I guess, sir.
Yes, sir. Yes, sir.
Okay, guys, if everybody is here, before I forget, let me tell you about your midterm. Okay. So you just submitted, I received some students midterm. I didn't have a look yet. Today, hopefully in the afternoon, I will have a look and send you some feedback. If everything is okay, you will get your score. Otherwise, you have to resubmit. If you don't want to resubmit, it's also fine, but I will deduct some scores, okay? Number 1, for example, file name. Okay, in the mail, if you remember, you can reread it. Okay, I mentioned that your file name must be M or math 252, and after that's what is it, midterm, after that your name, after that your surname. Now, for example, Sunhor, he just said, send me a Word file, there's no name, number one. And number two, all mathematical expressions you must type using math equation. If you didn't so, also actually there will be some score deduction. All right. Number three, and also design. Okay. And number four, did you put pictures or diagrams, anything related to your problem? Clearly, all right. And also the quality. And also I pay attention to this. Okay, okay. And after you finish, number one, you need to type the question first, then write solution, then you have to solve it. All right, you finish it, and after the next question, write that exercise number. For example, what you are solving. Okay, exercise, for example, 3.4, question 76. Under this, write the question, and under this, write solution, a line to the left, then you need to solve this. Okay. So, I mean, I will pay attention to this. And after that, of course, the solution. How did you describe or how did you write your solution? Okay, and these are the points that I'm going to pay attention to while I'm grading your midterm. And the deadline is, I think, tomorrow or Friday, I guess. Still you have time. If you can review, you may still resend it. But if you don't send it before the due date, I will just grade it accordingly. Okay? Is it clear?
So one question, can I just like take a picture or screenshot the problem and put it in the document
Take a picture of what?
of the problem instead of writing the whole problem?
No. You need to type everything. Only you can just copy and paste the picture. Okay.
Okay, sir.
Even for example, if you need to draw a graph, you can use Graphmatica or any tool, any graphing tool. Okay. You need to draw it and screenshot and paste it. It's fine. But the problem, solutions, everything you must type. If you don't type and submit, it's fine. But I will deduct a lot of scores for that. Because also I want you to learn how to type math questions. Okay? And that's also the
Yes, sir.
problem.
The solving math question, I mean, also fine. I mean, the equation and thing, we can write it, but the problem that's too long. That's why I just asked you if I can like take a picture of it.
Which problem is too long? I didn't ask any long question. It's just maybe.
No, sir. Some question is like half a page long.
It's okay. It's okay. But you need to type. You need to type.
Okay, sir.
Okay, actually, it's a practice. And I think you're not doing this on your telephone, right? You must use PC. If you don't have PC, also it's fine. You can come to Paragon University. We have PC in the library. You can use it. Okay, and this is not quiz, your assignments. This is just midterm. Do everything seriously. Okay. If you don't do this, it's fine. As I'm just reminding you, I will deduct a lot of scores. Okay. For each point missing, I will deduct 10 or 15 points. Just keep it in mind. And if you have any question about midterm, you may ask now. If you have anything, if you want, let me just show one midterm here. For example, I haven't checked it yet, but let's just open one. Yihing, for example. Okay, can you see that? Guys, can you see Yihing's paper?
Yes, sir. Yes, sir. Yes.
I didn't check it yet. All right, but here, this one means I think one, but you need to write question one, okay? Under this, what question is exercise 3.1? This question, you can write this. Okay, so for P of t, if this one. So I will check the question. If the question is the question like this or not, 3.1. If you didn't type the question completely, I will deduct some score for this. First here, there must be a question. Okay, there must be a question. Then after that, right here, solution. All right. For example, what I mean here is, for example, here, type your question. Type your question here. Okay. Before this, you should write here, if possible, in capital letters, question 1. Okay. Question 1, and right here, what is it? From exercise, let's say 3.1, and question, for example, 41. Okay. Type your question. You type your question, and after that, write here solution. Then write your solution here. Okay. You finish everything. Now you want to write your final answer. So here, LT. Right here we have, therefore, the 3 dots. Write your answer. My answer is this. Okay. Writing this question and the 3 dots, I can see that this is your final answer. This is how actually I'm expecting from you to do your midterm project or exam, whatever it is. Okay. Write here question number 1. From where? Exercise 3.1, question 41. What's your question? Write your question, then write your solution. If possible, you can change the color of this one so that I can see easily. Let's say everybody make it blue. This blue, for example. Oh, sorry, not highlighting. Just the font color. Where's the font color? Here, blue. And also your solution, for example, blue. Okay. So I can see that, only blue. Okay, here the solution, question, here is a solution. If it has any graphs, you can add it here, and your final answer with these 3 dots, write it here. Okay. And also this ln, we don't write ln like this. We l with lowercase l. And analyze the case, blah, blah, blah. Conclusion. Okay, hence also he showed his final answer like this. This is also fine, good. Okay, but when you're beginning, why like this, your question number 1. From where? Exercise 3.1, question 41. Type your question here, write solution, then solve it here, and finish answer like in the box or something like this. Guys, is it clear?
So if we have like figure in the problem, so can I just take a picture of the figure?
Yeah, if there's a figure in your question, you can either, you know how to make screenshot, right? Screenshots,
Yes,
cut
yes.
it, and paste it. That's also fine. That's good.
Okay, so yeah.
Okay. All right, then I'm closing this. Now let's continue. And the last thing, just one slide left. Okay. Solutions for x on x is not negative. At the beginning, when we were studying this Cauchy Euler equation, guys, if you remember, we assumed that x is non-negative, right? Because we did not want our solution of interval to contain 0, because our assumption was that x to the power m is the solution. And also actually we needed to, assume that x is not equal to 0, so that x to the power m is never equal to 0, so that we can divide both sides by x to the power m, right? If the interval solution contains 0, it causes a big problem. That's why we just excluded 0. If you want to include 0, we can just, investigate the behavior of the function 0 differently, because 0 is always a very special case, all right? And usually, in most cases, we are interested when, if you're talking about something related to time is greater than 0, okay? And here x is greater than 0. And how about if you're talking about something that x may take negative values, At the time, the solution of interval we can divide into two parts, right? One is when x is less than 0. Second case is when x is greater than 0. So in both cases, we can examine the question and after that we can draw a conclusion. For example, let's say for solution for x is less than 0. What happens here? We can just make a simple substitution. Let's say t is equal to negative x. If t equals negative x, I can make this change dy dx. What is x? X is negative t, right? And I can just change this thing into this. So dy dx becomes minus dy dt. And second order derivative of y with respect to x, if I just change this into t, right? At the time it becomes is minus, already actually also here we have one more minus, and it's exactly the same thing. But instead of plus, we have minus here. Then after that, we can continue our solution. And after we get our solution, again, we can make this substitution. Okay, instead of t, we can write minus x and display your solution. All right. Okay. What do we have next? A different form. A second order equation of the form like a times, instead of x, we have x minus x sub 0 squared. Y double prime plus b times x minus x sub 0 dy dx plus c times y equals 0. There's also a Cauchy Euler equation, right? Because let's see here, and also we can make this kind of substitution. Instead of this x to the power m, we assume that y is equal to x minus x sub 0 to the power m. After all, we want to eliminate this x stuff, right? So when we just do this substitution or this assumption and put it into this equation, then dy dx, it becomes m comes to the front, right? X minus x sub 0 to the power m minus 1. And the second one, if you differentiate one more time, second order derivative of this y, right, is equal to one more time m times m minus 1 times x minus x sub 0 to the power m minus 2. And after that, using again the substitution, instead of this x minus x sub 0, assume that that's equal to t. Okay? And also here we assume that x is never equal to x sub 0. And we just solve the reduced equation and resubstituting, we will get the solution of this equation. Okay? So this is also Cauchy Euler equation. How can we solve this? In our usual manner, we can solve this, and after that, to get the simpler form of the equation, we need to make this substitution. We should solve it, and after we solve and we get the answer, resubstitute this, right? And we can get the answer in terms of x. Because the original independent variable here is x. This one is just another parameter, right? After we get everything again, we have to resubstitute and get the answer in terms of x. All right. All right. Yihing, can you hear me?
Yes, sir.
Okay, Yihing, can you read what you see in the screen?
It is not our difference that divide us. It is our inability to recognize, accept, and celebrate those differences.
Yihing,
So
where do you live, in Phnom Penh or in province?
I'm in Siem Reap, sir.
Where?
Siem Reap province, sir.
Siem Reap. Okay, good. All right, guys, less than 6 minutes left. So I don't want to start a new section. Okay. So have some rest. After 10 minutes, we will continue. And do you have any question? Did you ask something?
Can I resubmit the midterm, sir?
Yeah, you can resubmit. It's fine until, what is the due date? Is it Friday?
Yes, sir, Friday, sir.
Okay, until Friday, you can change and you can submit. It's fine. Just let me know that you are resubmitting. Okay. And the students who actually replied their mails, that means it's not accepted. I didn't get anything. I mean, I didn't save their file. So they have to edit and send me in Word format, not PDF. Okay, PDF, I do not accept this. Because if I want to make some change, I cannot make in PDF. I can make, but weird. So you need to do this using Word, type everything there and submit in Word format. You don't have to submit PDF. Do not send me PDF format, okay? Just Word format, only one file. File name is math 252, and after that, midterm, your name and surname. That's all, okay? And also, if your file name is not correctly written there, I will deduct 10 points for that. Because from the beginning of this course, right, the semester, I have been telling you about this, but still students, they don't understand. Because if you send it in that format, I have to download it. I have to change it. I need to type your name and surname and everything. It is extra work for me. You have to do that. It's your job to do that, okay? You have your file name, M252, write midterm, name, surname, Word format, okay, and send it to me. That's all, okay? Okay, guys, let's have break. All right, and after we'll talk about 4.9. That's the last section of this chapter. Today I will finish this chapter, and tomorrow hopefully we will start next chapter, chapter 5. Okay, enjoy your break. See you after 10
Wait,
minutes.
sir, I have to
Yes.
send you through email, right?
Yeah, only email.
Okay, sir. Thank you.
Yeah, because this is official thing. In case also I will keep it in my email for a proof in case for the future. Okay, that's why you need to send by email using your university email. Okay.
Yes, sir. Yes. See you.
Okay. Thank you very much. All right, guys, enjoy your break. We'll continue after 10 minutes. Okay. See you.